Let's learn another relationship that can exist between classes and objects. This one is called inheritance. Now, when you think of inheritance, what do you think of? Usually it's you receive something from somebody else that you're probably related to. So somewhere along that family line, a parent object or grandparent object, or maybe an object above you, has given you something. That's the way it works in programming also. You can have a class out there, and then you can make another class and base it upon the previous class. And so that new class you just created gets everything that the previous class has. Now, what's the beauty of that? It means that a lot of your work could probably already be done. If you were a student class and you based that class upon a person class, the person class could have all these attributes and methods. And then when you go make your student class, you simply say, I want to inherit from the person class. And your class gets all the work that was previously done in the person class. And then you just have to go and make whatever changes you want to do to make your class more specific than the general parent class. Parent classes are more specific, and the further you go down in your inheritance, the more specific those classes become. You could have a child class called student. You could have another class called person. Above that, you could have human, or maybe you could even start with undergraduate student and go to student and then go to person. You have this big chain of inheritance. And every time one class inherits from the other, it gets everything. So if you had an undergraduate student that inherited from student, it gets everything the student class has. And if the student class inherited from person, then that undergraduate class also gets everything that the person class had. And that's why we like inheritance, because a lot of the work can already be done for you. If there's a class out there that's really close to what you want to do, you just make a brand new class, inherit from the other class, and then go make the little changes. For example, let's say that I'm the operating system, and this is examples in the book, but I like to use it. I'm the operating system, and I say, you're running your program, and I say, go clean your room. Now, you only know how to do one thing in cleaning your room, and that is you pull the sheet over the pillow and give it the little karate chop. And if you think that's going to work for clean method, or I mean clean your room, that is not going to work. And I'm going to GPF, blue screen of death, all over the place, and it's not going to look pretty when your program crashes. Because that's not what I really expected to have happen. I wanted a good, thorough, clean room. And so rather than letting your program die a horrible death, what could you do? Well, whenever you're in trouble, where do you go? You fall down, you get an owie, right? Remember what happened? You'd run to mom, and mom would kiss it better, and then you're all better, right? You always run to the parent when you need more help with something, and the parent can actually do a lot of the work for you. So when I say go clean your room, you know that your clean the room is not good enough, but you don't want to go and learn how to clean the whole room. You'd rather just have somebody help you. So you call your mom class, and the mom class is like, sure, I have a clean room method. Mom class, that functionality actually goes and makes the bed, dust, vacuum, everything. But when mom made the bed, she pulled the sheet off the pillow military style and folded the sheet flat. That's not what I wanted. I wanted you to pull the sheet over, karate chop. So the way you get around this is you say, hey, mom, I need your help cleaning the room. The mom class knows how to clean the room. And then you go back and pull the sheet back over the pillow and karate chop. You did one thing, you get all the credit. Mom didn't get the credit, you got the credit. How much work did you have to do? Hardly anything. And that's because you inherited from another class, you let the other class do most of the work, and then you just went in and did your little pieces. So what does that mean programming wise? Well, let's go ahead and create a program. We're going to create an employee class and a person class. Now, when you think of those two classes, who is more general? Employee or person? Who's more specific? Employee is more specific because an employee is a person. When you hear the phrase is a, that implies inheritance. So let's go ahead and create a brand new program, new file, and let's do a file save as, and I'm going to call mine inheritance.py. Call it anything you want. And we're going to go ahead and start off with our general class. Now the general class is the one that doesn't have as much information. In other words, it's more, sure, it could be that, it could be that. And so we're going to go ahead and start with the person class. Now, why is that so general? Because a fireman could be a person. A postal carrier could be a person. A student could be a person. A female wrestler could be a person. Any of those other classes is a person. And when you say is a, then that means a specific class is a general class. So when you do the is a, the left side is usually the more specific or the child class, and whoever is a points to is the parent class or the right side. And right side meaning of a phrase. So within the person class, let's go ahead and create a constructor, and I'm just going to paste some code in that has a constructor and a whole bunch of instance variables. Now, within those instance variables, those are a bunch of common attributes that a person could have. Every person has all of this, right? Every person has this information. The next thing I want to do is I'm going to go ahead and create a method. This is just a regular class. You've been making these now for the past couple of chapters. We make a class, and what this method does in this class is it says, if you ever call print demographics, then we're going to access the first name plus the last name and concatenate all this data. I dropped to the next line, so you notice I did the line continuation there. Notice I put that line continuation because I dropped down. We'll see later if that really works. Now that I have the person class done, we then think to ourselves, you know what? I need to make another class, but this class is a person. It's going to be more specific. And so we have the employee class inherits from person. That's how you do inheritance. You specify the name of the class, parentheses, and then the class it inherits from. And within this one, I want to go ahead and create a constructor. There's my constructor right there. And within that constructor, I want to go ahead and add some new instance variables. Now these instance variables belong to the employee class. But since employee inherited from person, it gets everything that the person class has. So by the time I create an employee object, not only does it have a salary and state, but it has a first name, last name, age, address, city, state, phone, and a print demographics method. It gets all of that. Now, what's cool about that? You didn't have to write it, and you're going to get all the credit for it. Let's go add a couple more methods to this class. We're going to add one called yearly raise, and that receives an increased value, and it just says go to the salary and increase that by the raise. Now where's salary? Well, salary's in the employee class. Okay, that's cool. Let's do another one, and it's called print raise. And there's our print raise, and it says simply call self.printDemographics with this string and that attribute. Now wait a minute. The employee class doesn't have a print demographics method. But remember it does, because since it inherited from person, it can call that method. It has access to all that stuff in the parent class. The work's already done for you. That's why we love inheritance, because I can now get my job done quicker and make more money. All I have left to do is let's go and gather data. So the first thing I'm going to do is I'm going to create an employee object. There's my employee object. And then in my employee object, I'm going to go ahead and gather information, not from the keyboard. I'm just going to hard code information for the attributes. Now, where did first name come from? Not from the employee class, but it got it from the person class. Why? Because employee inherited from person. Same thing with that attribute, that attribute, that attribute, and then salary you actually got from the employee class. And then we said, let's go ahead and call the yearly raise method in the employee class. And then let's go ahead and print the print raise method. Now the print raise method will go here and go there. Let's see what happens, okay? Let's set a breakpoint on line 26. Save your program, set a breakpoint on line 26, go to your debugger, and you should have already sent this up in the last video. It should say Python current workspace or the file. If you try to launch Chrome, it's not going to work. So make sure you're using the current file. Click the Start Debugging arrow. It starts the debugger. It's waiting for us to execute this. Ready? Let's execute. Step into salary, state, look at employee. If I look at the employee object, do a step into one more, the object's now created. Take a look at the employee object. I only see salary and state. Interesting. I wonder how I can do that. Well, what's actually happening here? So then I say, go to first name. Oh, the attribute's added. Go to last name. Go to city, phone, salary, year raise. Now watch what happens when I go into the print raise method. Now I go to demographics, and it jumps up here to the person class. And I can now access that method from another class. I'll click the blue arrow, just finish the running, and there's the actual running of it. So this is a way that you can create a base class, and then another class can inherit from that class, and it gets everything that the parent class wants to give it. And then you have access to it. You can call it, use it, do anything you want, and you hardly had to do any of the work at all. That's the power of inheritance.